In the telescope lab, you're going to combine two convex lenses to make a little telescope. You're going to find the magnification that the telescope gives you, and you're also going to discover that there's a new principle, a new problem that can arise when you combine two or more lenses. The problem is with parallax, has got to do with parallax, and it's called parallax error. I'll explain what that means in a few minutes. You've got the light box, you've got an objective lens, which is the one that's going to be closest to your eyes. That's got the number 100 on it, and allegedly it has a focal length of 100 millimeters. And there's another convex lens, allegedly with a focal length of 200 millimeters. And you've also got a screen over there. So the first thing you need to know is the following. I just want to mention some really basic facts about lenses or optics in general. They're really, really basic. So first of all, the definition of focal length for a lens, in fact for a mirror as well, is if you have plane waves incident on the lens, then you have parallel rays incident on the lens. That lens, if it's convex, will focus the rays at a certain point. So if they are parallel rays, the point that the lens focuses the light at is called the focal length. If the rays are not parallel, then the rays will not be focused at the focal length, they'll be focused somewhere else. For example, if the rays are diverging as they hit the lens, then the lens will focus the rays beyond the focal length. Now the reason for that is, well, you can think of it this way. The lens has only a certain amount of power available to bend light rays, and in a sense here it's coping with diverging light rays. It's already used up some of the power to bending power to cope with the diverging light rays. It's a very colloquial sort of way of looking at it, but look, it'll do. And so it's used some of its bending power to overcome the divergence of the light rays, and so they're focused beyond the focal length. So when you take the 100 millimeter or the 200 millimeter focal length lens and put it near a wall and open the blinds to the window and focus the trees outside onto the wall, the trees are not at infinity. The trees are only 15 meters away or 20 meters away. So the light rays from the trees are not exactly parallel. Actually, they're slightly diverging. So the focal length you get with the trees outside will be different to the actual focal length. The other thing to know is that there are sign conventions, certain sign conventions